Hello and welcome. Today in this video we are discussing condition for reciprocity for Z parameters or open circuit impedance parameters of a two-port network. First, let's understand what is reciprocity. Reciprocity. A network is said to be reciprocal if ratio of the excitation at one port to the response at the another port is invariant if excitation and response is interchanged. Means what? This is a two-port network. V1 and I1 are input variable, V2 and I2 are output variables. Now we are applying excitation at one port. Let's apply it at the input port, Vs, excitation. When we are applying excitation at the input port, this V1 becomes Vs. Now we are measuring response at the output port. Another port means output port. Now we are measuring response means we are finding current through this output port. So this is I2 dash. So when I2 dash we are measuring, we are short circuiting this output terminal means V2 becomes 0. Now we want to find reciprocal network means what? The excitation at one port and response at the another port, and if we are taking the ratio of it excitation and response, that means Vs upon I2 dash, and if we interchange the excitation and response, that means excitation will apply at output port and response will measure at input port, and whatever that ratio should be same or invariant. Let's see. We want to see the condition for Z parameter in terms of Z parameter for the network to be reciprocity or reciprocal. So case 1 will apply excitation at the input port Vs and response will measure at the output port, that is I2 dash. Why we are labeling here I2 dash? Because I2 is also output variable, current variable, but we are considering the direction coming inside the two port network, and response should be always coming out from the network. That's why I2 dash. Now these are the standard Z parameter equation. V1 and V2 are expressed in terms of I1 and I2. We want to find a condition so that network will become reciprocal, and that condition we want to find in terms of this Z parameter. So here for this case 1, V1 becomes Vs, then I2 becomes I2 dash, and V2 becomes 0. Now let's put this value in our Z parameter equation. V1 is equal to Vs, Z11 I1, and I2 becomes minus I2 dash. That's why this minus I2 dash. I2. Put this value in equation 2 also. V2 is equal to 0, Z21 I1, and I2 is minus I2 dash. So this way minus I2 dash. Now from this second equation, we'll replace I1 in the first equation. Why? Because we want to take ratio of excitation and response. Excitation is Vs and response is I2 dash. So we don't want this I1. So we have to express this I1 in terms of I2. So we'll use this second equation. From second equation, we'll get I1 is equal to Z22 upon Z21 I2 dash, and we'll put this I1 in the first equation, and we'll get Vs is equal to Z11, this I1 we have replaced, and minus Z12 I2. Now we can take I2 common and we can take a ratio of Vs upon I2 dash. Vs is excitation, I2 dash is response. So here by taking I2 dash common, we'll get ratio of Vs upon I2 dash. It is equal to Z11 Z22 minus Z12 Z21 divided by Z21, where Vs and I2 dash, it is a ratio of excitation and response. Here excitation we have applied at the input port and response we have measured at the output port. Now we'll interchange this condition of excitation and response. That means excitation now will apply at the output port and response will measure at the input port. Let's see case 2. In case 2, excitation and response has interchanged. That is, this is our two port network. We'll apply excitation at the output port and response will measure at the input port. So, for Z parameter equation, what we need to change? Our V2 becomes Vs, excitation, and V1 becomes 0 and I1 becomes minus I1 dash. Now we'll put this value in our Z parameter equation. First equation, V1 is 0, I1 is minus I1 dash and I2 as it is. Similarly, second equation, V2 becomes Vs minus Z21 I1 dash. I1 becomes minus I1 dash plus Z22 I2. Now we want the ratio of excitation and response. Here excitation is Vs and response is I1 dash. So we have to replace this I2. So I2 will replace from equation 1. From equation 1, I2 is equal to Z11 upon Z12. Put this value I2 in equation 2 and we'll get I2. Now we can take I1 dash common to get ratio of excitation and response. So I1 common and Vs upon I1 dash is equal to Z11 Z22 minus Z12 Z21 divided by Z12. So here we have taken ratio of excitation and response. So in both the case, we have taken ratio of excitation and response. Only the change in first case, excitation is applied at input port and response is measured at the output port. That's why ratio is Vs upon I2 dash. And in second case, we have applied excitation at the output port and response we have measured at the input port. That's why the ratio is Vs upon I1 dash. Now, according to the definition of reciprocal network, a network is said to be reciprocal if ratio of excitation and response, excitation at one port and response at the other port is invariant, or we can say remains same if excitation and response has interchange. So we have taken both the ratio by interchanging excitation and response, and these two ratios should be same. Then only we can say our network is reciprocal. Now you can check this ratio. Numerator is same in both the case. To get this ratio equal or same, this denominator should be equal. So here we can conclude that to get this both the ratio equal, your denominator should be equal. Numerator is already same, only denominator should be same. That's why the condition for reciprocity in terms of Z parameter is Z12 is equal to Z21. In this case, question can be like this. For any given network, two-port network, find Z parameter and check whether the network is reciprocal or not. In that case, what you have to do? Find the Z parameters. How to find the Z parameter? That we have explained in another video. And check whether Z12 is equal to Z21 or not. If Z12 is equal to Z21, then we can conclude that the given two-port network is reciprocal. And if it is not, your network is not reciprocal. So this is about the condition for reciprocity to check whether network is reciprocal or not, and that condition is in terms of Z parameter. So if we know the Z parameter, we can check or examine whether the given network is reciprocal or not. Thank you.